Hello, everyone. Uh, Today we'll be talking about monitoring services and not service. The world has been moving towards microservices and API-driven architectures from the more monolithic application architectures. And this move has got a significant benefits in case of delivery speed and scalability. But on the flip side, it also added significant things to deal with, like the operational complexity in the managing, monitoring, and securing the services or distributed architectures. And we will see how monitoring services is way more important than monitoring servers in this whole complicated scenario we are dealing with. So I'm Jayesh Ahire. I'm a product manager here at Last9, and I'm also AWS Machine Learning Hero. You can find me on Twitter at Jason_Ahire1 if you want to discuss anything more about around tech or anything about around observability for that matter. Let's just go through a set of expectations and measures the companies are following in this whole chaotic distributed architecture scenario. So let's start the incident, right? So I will start the story. And I used to work with this fintech organization in the past. One day there was a big incident. So basically, a big event was happening, big sport event was happening in the country, and the incoming payment request started increasing, and suddenly payment started failing. So being a payment company, every second of failure was basically resulting into a loss in revenue as well as loss in reputation at that matter. So the business folks asked engineering and ops about why the failure has happened in the first place, and the response was payment services up and running, and it wasn't down at all in the last few hours. So basically, the servers were doing their job well. And the whole fiasco was happening because of some third-party gateway failure, and essentially because of a drop in success rate of the payment service in general, than the whole payment service being down. The service was never down. The servers were fueling the uptime of a service, but at the same time, there was a third-party gateway which was talking to a payment service was resulting in the failure. It took them a couple of hours to figure this whole thing out, and in between there was significant loss in revenue, and it was unrecoverable for that matter. So in this case, the business reaction was there's a lack of easy way to correlate business impact with the incident, and they blamed IT for incident in that matter. So how ops reacted to the whole thing is ops went ahead and started collecting more metrics to avoid more such incident in the future. And they created correlations and created more dashboards, and everything was viewed around servers. And then again, I want one more alert syndrome kit. And then we configured one more alert to get alerted whenever the servers went down or whenever there's an impact on the uptime availability. So, what were the business expectations in this case? So, business expected responsive and error-free services. Whereas what business measure to for this is they measure speed and quality to signify that the responsive and error-free services. What is success for ops? Ops success criteria: high availability, no resource exhaustion, low cost of infrastructure. And what ops measures to do that is they measured resources like CPU, memory, disk, basically servers for this matter. Then what it resulted in? It resulted in huge metric collection and storage infrastructure, alerts going 24/7 causing fatigue, metrics which are spread across multiple products, and there's no way to objectively measure your system. So what do we want out of this? We want a simpler, more responsive observability, which is aligned with the business, and we want faster paths to improvement because what gets measured gets improved. And the way there. So how can we get there? We can get there by monitoring services and not really servers. We can focus on the service level metrics and service delivery, which are key in this whole scenarios, than focusing on servers in the first place. So let's just talk about SLIs then, because SLI is an indicator or metric which shows how well your service is performing. And let's just align this whole thing with the business, right? So the business goals in this case are we want speed and quality, and the good SLIs in this case are latency. Like the good SLIs are latency, uptime, availability, error rate, whereas the bad SLI choices might be resource consumption, cache hit rate, garbage collection time, because those are really associated with the server level metrics and not really the service and service delivery in this matter. So what is a good SLI for that matter? The good SLI is something, an indicator which is very relevant to service delivery. It is clear and unambiguous. It is easy to communicate to all stakeholders, including the non-technical people or business people. Common language for the entire organization to measure performance objectively. That's what we can call a good SLI. And in this case, as we can see, the if I go and talk to my business and say my cash hit rate has increased or decreased, it doesn't really signify anything for that person. But me saying that my availability went down is a good enough measure for them to understand the impact. So basically, to start putting SLOs, start configuring SLOs, the first thing you have to do is identify the type of the SLI for your service. So there can be multiple type of services, right? There are consumer facing services, there are stateful services, there are asynchronous services, and there are operational services. So I won't go into details of this because these are general terminologies. So, but this table basically tells you what indicator you should be choosing for particular type of services. For consumer facing services, we should the availability, latency, or throughput is a good SLI. For stateful services, latency, throughput, correctness is a good SLI. For asynchronous services, throughput, correctness, stat, or lag are the good SLIs. Whereas for operational services, the availability, correctness, and that lag becomes the become good SLIs in this case. And what do we do with SLIs? So we basically set SLOs on top of SLI, which will help us objectively measure our system and on the basis of service performance, right? So SLO is basically a goal for your SLI. So SLI is here is latency. SLO is latency should be below 300 milliseconds 99% of the times. And SLA basically states what if SLO is breached or what if SLO is not being obeyed by any of the parties. So what's a good SLI looks like? Good SLO looks like. So the good SLO is latency should be below 300 milliseconds 99% of the time, so the period of 7 days. Well, latency is our indicator. Below 300 milliseconds is our goal. The 99% or target, 99% of the times is a compliance target, and over the period of 7 days is our compliance window. So this is how a good SLO looks like, and this is what we configure to measure our services objectively, to measure our services and not really servers. And that's it for today. So if you want to learn more about this, we have a few good interesting blog posts. I have linked them here, so you can go through them. And thanks. So if you have any questions, please find us at SLO Computer on Twitter, me and Jayesh at lastnight.io, and I will be happy to answer any of the questions.